In this video, we will look at the RAS systems named C and D in the facility. They are located behind these green tarps. Both of these systems are set up almost identically, with the exception of some extra filtration on system C. So the tanks on the right, the square tanks with water circulating in them, they are part of system C, and the tanks on my left, which are shallow rectangular tanks called raceways, are system D. So system C is comprised of 12 tanks, and they are stacked in 2 levels. And I'm currently running this system for an industrial project which is about to start in the coming weeks. So as you can see, the tanks are square, however they have rounded corners, and we like to call this design a semi-square tank. You can notice that the water inlets are not submerged at this particular time. They are just trickling in, and that is because we are going to be holding snow crab in here, and they do not require directional flow. So the system layout is pretty simple, and it includes most of the components that research systems generally contain. System D is easier to access right now, and I'm going to use it to illustrate or to show the way water flows within both systems. So we can see our tanks here. Water would enter on one end and exits on the other end. That water then flows back to our sump. Now this system is shut down right now. So we can also see that on our sump we actually have a small protein skimmer that adds an extra level of filtration. So from this perspective, we can see how things are set up a little easier. So we have our protein skimmer here, which draws water from the sump. We can see various piping here for overflow of our header tanks, and also for addition of our makeup water. So generally speaking, water leaves our tanks, it goes into the sump, where it's then pumped by this pump up and in through our titanium heat exchangers, or excuse me, exchanger, and from there water goes to our header tanks. Now this system is a little different in that we have 2 header tanks. The first is actually a biofilter that has biomedia inside of it, and this type of biofilter is just utilizing biomedia in a static manner. So that means that the biomedia does not move as the water flows through it. So water fills up from the bottom, and then it overflows at the top here into the next tank. And this tank is technically only a header tank. And from here, our water flows out of the bottom of the header tank and then back into our tanks. Now you'll notice that there are some extra fittings and hoses and whatnot coming out of these header tanks. We can see one here that has a black PVC hose coming out of it, and we also have another one right here that is a rigid insulated pipe. And these two extra outflows are actually what we call our overflows, and they dump directly back in to the header tank, or excuse me, the sump. And the reason we have those are to help minimize the amount of overflowing in our biofilter and our header tank. And this one in particular on the header tank ensures us, or indicates to us that the header tank is full, which is the condition that we want to see to ensure the best water flow into our tanks. You can also see these small red handled valves here, and they actually provide ear stones that are located in the bottom of both the biofilter and the header tank. So they provide, they do two things. Those ear stones provide oxygenation for the system water and the bacteria that colonate the biofilter, and they also do a certain amount of degassing to remove carbon dioxide. So I have just explained and shown the layout for System D. System C is designed exactly the same way. There are two exceptions though. You'll notice that there is no particulate filtration going on in System D. And as I said, System C is designed exactly the same. But we realized that for System C, that if we wanted to hold salmonids or any other finfish, that we would have to add some level of filtration to remove, waste feed and feces. So what we decided to do was to add a series of filters, and these are called bag filters, for the obvious reason that the filters that they use are kind of a mesh bag. And we can see here that we have 4 canisters, and each of those hold one of these bag filters. These filters are a plastic woven material that can be reused if they're cleaned properly and dried out. The problem with this type of filtration system is that once the bags, once the material the bags are made from becomes completely blocked with waste material, then they completely prevent water flow through them. Unlike an automated particulate filter like a drum filter, there's no kind of automated cleaning. So we have to keep a close eye on these bag filters to make sure that we're changing out the bags routinely, because we don't want water to stop flowing. So that's part of the maintenance that's required for this type of system. And if you do your routine maintenance and you change out these filters as they are needed, it works very, very well. The actual filters that we use, the bag filters, are available in various different sizes. So everything right down to 1 micron and then right up to 1 millimeter or even larger. If we follow the way the water flows here, we can see that The water actually comes in on the top, flows down through the filters, and then comes out the bottom. And if we follow the way the water flows, you can see this black vertical plastic vessel here. This is a UV sterilizer, and this happens to be a high output UV sterilizer, and we decided that we would add an extra level of filtration into this system. So we decided to put a UV sterilizer in place. So after the water has been filtered, then it is very clean. However, there could still be some bacteria in the water and other pathogens. And after it goes through this UV unit, the water is sterilized. So water then travels back into the sump where it is pumped back to the fish. So in System C with the square tanks, we tend to use these tanks for salmonids or other small fin fish. And in System D, these tanks are really good at holding shellfish, like lobsters, mussels, oysters, really any fish that needs a low depth of water. And of course, you wouldn't want to put any fish in here like a salmon that likes to jump or splash, because the tanks are very shallow. And these two systems are quite small. You're looking at about 2,500 liters for System D and maybe 3,000 for System C. So because of their small volume, we tend to do any work in salt water in these tanks because of the low volume that they require. These systems do not have as much monitoring capability as our other systems. We are only monitoring temperature and pH and water flow in these systems. We do not have any oxygen monitoring. In fact, we have no in-tank monitoring of any water quality parameter. We do, however, have very good temperature control in these systems. When we refitted this system a few years ago, we actually replaced our heat exchangers with high-end and high-capacity titanium heat exchangers, like the one you can see here in front with the blue insulation on it. And the heat pumps that provide the heating and cooling are actually oversized for these size of systems. So we have a very high capacity to control temperature. And we've never tested the upper temperature range that we can achieve, but we know that we can get 0 degrees in these systems when we're running salt water. So they're very useful for running experiments where temperature stress is something that you want to look at. Hopefully in the coming weeks we'll be able to get you guys into the Institute and you can see and work with these systems firsthand.